Let's add and subtract rational expressions without a least common denominator. So we're going to look at polynomial denominators, denominators where there's some kind of adding and subtraction in there. So in order to add and subtract, you need common denominators. So the way you get a common denominator is you need to actually multiply the fractions in order to change the denominator to something else. So once we get a common denominator, we can just put the pieces, the numerators together. So for opposite expressions, like a minus b and b minus a, you can actually multiply by -1 in order to make them equal. So at first glance, 9 over x minus 5 plus x plus 2 over 5 minus x, these denominators look like they're the same. The commutative property says that expressions are the same in either order if you are adding or multiplying. And this is subtraction, so it doesn't work. So what we can do is we could take one of these fractions and multiply it by -1. So standard form, we usually write the x or the variable first. So we're going to multiply this second fraction by -1. What happens to our second fraction when we distribute this -1? Our numerator becomes -x minus 2, and our denominator becomes -5 plus x. Our first denominator, or our first fraction, stays the same. Now these denominators, -5 plus x, because it is addition, we can rearrange this and write it as positive x minus 5. Now these denominators are the same. So again, we're going to write it as x minus 5. We are not going to write it with the -5 plus x. So our denominator is going to be x minus 5. Our numerator is going to be 9 plus -x minus 2. And all we have to do is combine like terms. So our numerator is going to be -x, and then 9 minus 2 is 7. So -x plus 7 divided by x minus 5. That would be our answer for this one. So some problems get a little more complicated. We're going to do 3 in total. So the second example has denominators that hopefully you can see look similar. So we have 16 divided by 3x plus 3 plus 3 divided by 4x plus 4. So we know we're going to have to multiply to make these the same. Sometimes when you see denominators, they'll be the same, they'll be opposites. Most times you're going to have to factor them out to figure out what's hiding. So the 3x plus 3, that has a common factor of 3. So we could take 3 out, and if we divide it out, we're left with x plus 1. The 4x plus 4 similarly has a 4 common factor, so we can take that out, and we're also left with x plus 1. So to make these denominators the same, both of these denominators have x plus 1 already. The first fraction has a 3, so we're going to have to multiply 3 to the second fraction on top and bottom. That shows us that now they both have an x plus 1, and they're both going to have a 3. The second fraction has a 4 in the denominator, but not in the first one. So the first fraction we're going to have to multiply by 4. You can see the denominators now have 3 distinct pieces. 4 times 3 times x plus 1. 4 times 3 times x plus 1. So these denominators will be the same. So all we have to worry about is our numerators. 4 times 16 is 64. 3 times 3 is 9. And our denominators are going to be equal. 4 times 3 is 12. So we have 12 times x plus 1. 64 plus 9 is 73 over 12 times x plus 1. So this is in factored form. This answer is correct. Sometimes your teacher might want you to actually simplify the denominator. So if that's the case, you just distribute the 12 and you get 12x plus 12 as your denominator. But again, both of these are mathematically correct answers. So now we have an example where we factored. The next one's also going to be factoring. They're just not going to look as pretty. So 6 divided by x squared minus 9 minus 2 divided by x squared plus 6x plus 9. So same deal. Hopefully you see these, you notice the denominators, and you're like, okay, these have to be factored, and hopefully you know how to factor these. X squared minus 9 is a difference of 2 squares. So that's going to factor as x plus 3 times x minus 3. The x squared plus 6x plus 9 is a trinomial. So we're going to write that as x plus 3 times x plus 3. So now we have our expressions factored. Now we could look at the denominators and figure out what's missing. Both denominators already have an x plus 3, so that's fine. The first denominator has an x minus 3, which does not exist in the second denominator. So I'm going to have to multiply the second denominator by x minus 3. And now those are the same. The second denominator also has an extra x plus 3, which means I need to take that extra one and put it on the left side. And all of this comes down to making sure these denominators are all exactly the same. There are 3 binomials being multiplied in both denominators. So there's no double dipping here. So now each denominator has double dips, or has the same 3 binomials with no double dipping. Now we can just focus on our numerators. So we have 6 times x plus 3, and then 2 times x minus 3. And our denominator is going to be the same. It's going to be x plus 3 squared, since there's 2 of them in the denominator, times x minus 3. And now we're just simplifying numerators. So we get, just for the numerator, 6x plus 18. This is a minus 2, so we could add negative 2 and distribute that. Negative 2x plus 6. So our numerator is going to be 4x plus 24. And then the denominator is going to be x plus 3 squared times x minus 3. So that, again, is mathematically valid. That's the correct answer. You can rewrite this if you see it. You can rewrite this and factor the numerator. You can take out a 4, and then you're left with 4 times x plus 6 over that same denominator. So that can come in handy. Sometimes there's going to be hidden pieces that you are able to divide out, and that's just going to come with more practice as you keep doing problems.